All right, we went over the transformations. We went over this chart, so if you didn't get it copied down, pause the video and copy it down. But we went over this with a little bit more details with some examples, so hopefully those examples specifically really made a difference here. And so now to our first example of the lesson, we need to write the functions hoots and then meet the description. So these first three have to do with horizontal and vertical shifts. I'm just going to cover up the rest real quick. We need a graph of y equals x cubed who is shifted to the right 4 units. So I've got my horizontal shifts, which means this needs to go inside of my function. So this is going to be y equals x something cubed. This needs to go inside. That's what this is saying here. And if it is going to the right, then it needs to be the negative version of that. So this is going to be x minus 4. We need a graph whose y equals the square root of x is shifted down 4. When it is shifted down, it goes at the end of your function. So this is y equals the square root of x minus 4. Inside the function for left and right, your horizontal. Outside the function for vertical, up and down. The graph y equals the absolute value of x is shifted to the left 4. Because it's left, it's going inside. So y equals the absolute value of x. This needs to go inside of my function. If it's going to the left, it needs to be positive. So plus 4. The graph of y equals 1 over x, but is shifted up 4 units. When it is shifted up, it goes on the outside of your function. So this is 1 over x, now plus 4. The graph y equals x squared, but is reflected about the x-axis. When it is shifted across the x, the negative goes out front of your function. So this is y equals negative x squared. But on this one, when the graph y equals the cubic root of x is reflected about the y-axis, now that's inside of my function. So this will be y equals the cubic root of negative x. Outside the function, inside the function. G. The graph 1 over x, but is vertically shifted by a factor of 5. Okay, when it is vertically shifted, it goes right out here in front. If my factor is 5, then this becomes 5 times 1 over x. Now, if you want to leave it that way, that's perfectly fine, but you can simplify this one. 1 times 5 is 5, and then keep that all over x. So those are the same thing, 5 times 1 over x or 5 over x. And then if it is vertically compressed by a factor of 1/5, it still goes out front. So y equals 1/5 times the square root of x, which again, you can do the same thing. 1 times the square root of x is the square root of x, and then it'll stay all over 5. This and this are the same, both are acceptable. Now on I and j, we're going to have multiple shifts. The graph of y equals x cubed, but is shifted to the, it's supposed to be to the left 6 units and shifted down 3. Okay. When we are shifting vertically, which is down 3, That goes on the outside of my function. So if I'm going down 3, those signs are the same. Down is minus, so this is -3. And then to the left 6, when it is going left and right, it goes inside the function, which would be here in the grouping in the parentheses. And we are going to the left. When we go to the left, it is positive. So this is +6. Okay. The graph y equals the square root of x, or I keep saying square root of x for absolute value. The graph of y equals the absolute value of x, but is shifted up to, reflected about the x, and is vertically stretched by a factor of 2. Okay. Well, let's start with the reflected along the x. When it is reflected along the x, that's going to go out front. So negative. It is vertically stretched by a factor of 2, which also goes out front. So now this is a -2. And now we have the absolute value of x that is shifted up to. When it is shifted up to, that goes outside. So this is the absolute value of x plus 2.